Let's talk about the pH scale and the autoionization of water. So when we say autoionization of water, what are we talking about? We're talking about water and water coming together in a reaction to make its ions, a solvent cation, hydronium, and the solvent anion, hydroxide. That would be the autoionization of water reaction. And so there is a K associated with this, K, and we call it KW for water. And that's going to be equal to the concentration of hydronium in solution times the concentration of hydroxide in solution. And at 25 degrees Celsius, this happens to be 1.0 times 10 to the negative 14. Neutral water, when we talk about neutral water, the concentration of hydronium will equal the concentration of hydroxide. We'll have acidic water, where the concentration of hydronium compared to the concentration of hydroxide is larger, or the concentration of hydronium is greater than that of the concentration of hydroxide. And as you can probably guess, basic water is the opposite, where the concentration of hydronium is less than that of the concentration of hydroxide. So neutral water, if we take the, if we say that the hydronium and hydroxide are the same, that would give us X times X equals 1.0 times 10 to the negative 14th. Well, our X squared is 1.0 times 10 to the negative 14th. It's square root both sides. X equals 1 times 10 to the negative 7th. I'm going to erase that. 1.0 times 10 to the negative 7th molar. I take the negative log, mathematically, the negative log of Kw, and I take the negative log of hydronium plus multiplication, negative log of hydroxide equals the negative log of 1.0 times 10 to the negative 14th. Why is it negative log? Well, because these exponents are less than 1. They're negative exponents, which means we need to do the negative log to get a positive number. So the negative log of Kw, we're going to abbreviate that as pKw. Negative log of hydronium would be pH. Negative log of hydroxide we're going to call POH. And of course the actual value then would be 14. So pKw is 14. Conversely, if we have these powers of hydrogen here, powers of hydroxide, so you can see here this is equal and this is equal. This means pH is equal to the negative log of hydronium, and POH is equal to the negative log of hydroxide. Doing it the other way, hydronium here equal to 10 to the negative pH. pH is going to be equal to negative log of hydronium. POH is negative log of hydroxide. If for some reason though I need to figure out the hydronium concentration from the pH, I can use 10 to the negative pH, and conversely for hydroxide, 10 to the negative POH. And if you look at the calculator, log and 10 to the x, they're inverses of each other. So I'm not sure if you've covered that in math or not. Either way, it doesn't matter. Same button on our TI 83s, 84s. Log, because log is base 10. And so I can do, if I have a pH of 14, I can do second 10 to the negative 14, and I'll get 1 times 10 to the negative 14. Works out beautiful. That's pH, POH. So let's look at the scale now. And if I talk about my concentration of hydronium versus my concentration of hydroxide and the pH, we look at the pH always through the view of hydronium. So we got pH is 0, 1, 2, let's skip to 7, 9, 12, and let's go to 14. If my hydronium concentration is 1.0, my pH is 0, because a negative log of 1 is 0. If it's 0.1, 1 molar, this is all molarity, right? Or 10 to the negative 1, pH is 1. 10 to the negative 2, or 0.01. This is 10 to the negative 7th molar. 10 to the negative 9th molar. 10 to the negative 12th molar. 10 to the negative 14th molar. So it's a 10 times increase or decrease each way. Hydroxide starts off at pH 0. The pOH would be 14. So we have 10 to the negative 14. pOH is 13, right? Because pH plus pOH is 14. So this is 10 to the negative 13 molar. 10 to the negative 12th molar. 10 to the negative 7th molar. 10 negative 5th molar. 2 and 0. 10 to the negative 2 molar and 1.0 molar. So that's our pH scale. Right here, we are going to be considered neutral at that moment. This way is acidic, and this way is basic. And that's how we look at that. That's the pH scale.